Okay, here we go. You are grading. Your butt out now. Okay, you are grading your quiz. If you missed it, just put a mark for the number. Okay, you can correct it, but make sure that's the mark for the number. You will grade up until part D, the back part with the free response stuff. I will grade all of that, so you can't correct it because I need to grade it still. So once we get there, I'll remind you again to not touch it, but you can do everything else, and you'll need to grade up until that point. So here we go. Number one was the formula for lead cyanide. So lead, PB, that 2 tells me that it's oxidation number, which goes above it right now. Then we have cyanide, of Cn, -1. Cross them up. We now get PbCN2. There has to be a parentheses around the Cn, or else you got it wrong. There has to be. If you put the 2 on the inside of the Cn, that's wrong as well. Listen, this is cyanide, correct? That is not cyanide. Because this we have 1 carbon and 2 nitrogens. The correct way, we have 2 carbons and 2 nitrogens, right? It makes a difference. It does, okay? So anytime you have a subscript with a polyatomic ion, that subscript has to be on the outside of the parentheses, and you need the parentheses there. Okay? Next one. What type of bonds are formed? We have phosphorus and oxygen. So up here, you really should have been telling yourself we have a metal with a nonmetal. Down here, you should be telling yourself you have nonmetal. That's covalent, right? Which means C and D are out of the question. From there, we know that covalent has prefixes, right? The prefix for 2 is di. The prefix for 4 is tetra. A is your answer. Okay? You have got to really start asking yourself if what combination you're making is ionic or covalent, if you haven't already. And just a heads up, your test on Thursday, I don't remember too many covalent questions as far as like the reactions go. I'm not saying there's not any, because there probably is now that I'm saying it, but all of what I remember is almost exclusively ionic. So Roman numerals, polyatomic ions, acids, naming and writing out acids. Okay, those are the big things for Thursday for you. Number 3. Real quick, how many of you picked A?
I almost did.
Somebody picked A. Nobody wants to tell me? Well, good. Here's the reason why nobody picked A. What were you going to say?
Because it's not necessarily showing the, like it's not like the basic synthesis that's like A, B, like D is, and it looks combined.
Synthesis is A plus B gives you AB. We did that in the warm-up, right? And you're thinking, well, there's 2 things here, so that's an A and a B, right?
Yeah, I forgot what. Yeah.
Well, that's not true, because what is that thing?
It's a polyatomic ion.
Polyatomic ion, which is just an A. This H2O2 is also a polyatomic ion, which is your B. Okay? So from there, synthesis is correct. So that doesn't answer our question of identifying the wrong one. Okay? If you work all the way through A plus BC, that is single replacement. A plus BC again, that is single replacement. This was a more clear-cut synthesis, so that one's correct as well. Down here we have A, B plus C, D. So right away from that, we should say that that is what? Double. There should be double replacement. So E is the misplaced naming. Is the wrong identified one. Okay? Number 4. Number 4 comes directly from your notes, word for word, same number. Okay? If you have 46.5 grams on this side of your equation, how much do you have to have on the right side?
I was sitting
Because it's supposed to be 1,000.
I sat there, I was like, how am I supposed to add this number into the, I was.
Now, here's the thing. When I tell you that this is word for word from your notes, it is letter by letter, word for word. We even use the exact same number. Okay? It was on there. If you don't believe me, go look.
I
Okay?
remember doing that.
Now, on your test, it might get a little bit more difficult. And when I get more difficult with these, it just means I'll give you a value for each one of these, and each one of these, and I'll leave one of them out, and you got to find the missing value. But you need to know this basic one before you can find any missing values. Okay? Number 5, which of these does demonstrate the law of conservation of mass? So with these, we can get as simple as 2 different types of circles, or as complicated as 3 different types of circles, 3 squares, 3 triangles, all different shades. It doesn't matter how complicated it gets. What you're looking for is the same amount of that shape on the left side as the right side. And the same amount of that on the both sides. Okay? And so B is the one that does that. We have 3 circles here that are clear, 3 circles that are here. Even though they're rearranged, that means a chemical reaction has occurred. That's fine. All right? But we have the same amount on both sides. That's what the law of conservation of mass is. Any questions 1 through 5? Okay, you should still be grading. Make sure you're marking these up if you need to. Number 6. Now, number 6, technically, all I'm looking for is a 3 in that little placeholder. Okay? Now, if I grab my answer key, you should have also had a 2 here and a 6 here.
Oh my, no way.
Now,
I understand.
No.
listen. If you put a 3 here, you got this question correct. Even if you missed those 2, because I'm asking specifically about magnesium. However, if you didn't get those other 3 right numbers, I need to know, have questions about why you missed it and why you didn't balance it the right way or whatever it may be.
I thought it was so.
I
Okay.
thought I was wrong, but I'm
I'm like doing good.
Nope.
actually
Most people have up until part D.
Well,
So we'll see. But that's a good start. Good. It should be. Number 7, which of the following statements is true regarding single replacements? Now, anytime you see single replacements, what chart should you have in front of you? Your activity series chart that has kind of like a hierarchical system of what is more active than another thing. So what you will find is that chromium, bromine, and iodine all fall lower on the chart than what they're paired up with. What I mean by that, chromium is lower than manganese.
Where did y'all see chromium?
Yeah, where do you see that at?
Chromium is not
Listen, bromine is lower than chlorine. So let's say you didn't find chromium on there. You could have asked me. Or you could have seen that iron for sure is higher than copper.
Yeah, that's what
I just assumed it wasn't on there, so it was automatically wrong.
Yeah, I was
Okay,
like, oh,
that's
that's
fine.
wrong. So I
That's
just-
fine. There's not anything like that on your test. We've checked over that part.
But
Okay.
is that actually like supposed to be?
Is that
Yeah.
oh.
Well, I'll change it next year. So D is your answer because iron is the only one that is more active than what it's trying to replace. So this reaction, whatever that is, will take place. Will take place, all right?
So we start creating.
No, not yet.
Oh, until section D.
All right, I need y'all to calm down for a second. I I need y'all to calm down for a second. Okay. You're still grading. You're still grading. Now we start to get a little bit, well, besides the true and false, we start to get a little bit more involved, a little bit more complicated, okay? Now here's where you're going to want to kind of write some notes down because I'm giving you a hint with some of this stuff, okay? Now, H3PO3, you all should be able to identify as a what?
Yeah.
This is an acid. The big indicator is that hydrogen right there, right? Every acid will have a hydrogen to start off. I've said that a million times in here, right? What you don't know, but now you will, is that this hydroxide, this OH, indicates a base. Okay? So if you know anything about acids and bases, acids are just kind of the opposite of bases. Okay? Hydrogens are to acids as hydroxides are to bases. So every base will have a hydroxide in there. Y'all get that analogy? Every acid, listen, every acid has a hydrogen in it. Right? Those are kind of like the pair, right? Every base will have a hydroxide in it. What?
Something that has oxygen in it. Is that why you drink it?
Yes. Yeah, I'll talk about that here in a second. So, every time you have an acid and a base being put together, you have a special type of reaction called a neutralization reaction. What do I mean by neutralization? Now, listen, for all of you thinking like, why are you asking this question if we didn't know it? You could have got this completely correct, and most of you will get it correct, without knowing any of this. I'm just giving you kind of a shortcut on some of these, okay? Every time you add an acid and a base, what you end up getting, no matter what acid it is, no matter what base it is, you always end up getting some type of salt water. Okay? Why do we call it neutralization? Because just like Mary said, when you have heartburn, which is acid reflux, it's your stomach acid, you take an antacid, which is a base. Why do you take an antacid? To neutralize the acid that's coming up from your stomach. Okay? If you get into any type of environmental job or a hazmat job and you have an acid spill for someone's transporting acid for whatever reason and it spills, how do you clean it up? You throw a base on it. Okay? And then what does all that acid turn into? Salt water. Now, you have to get away from salt as that white powdery stuff that's on your dinner table. That's table salt. That's a certain type of salt. Really, any salt is any type of ionic compound. Okay? So salt is a very, very general term. Okay? Hopefully you know that now. Okay? So knowing this, what you probably came out with your products to be is aluminum with phosphate and HOH. Did anybody have that written down?
No.
You should have,
Oh, yes, I did.
because this is a, hold on. This is a what type of reaction? Guys, listen. Listen. The question that I just asked had really nothing to do with what I talked about with acids and bases. You need to be able to recognize this as a double replacement reaction. Right? If it's a double replacement reaction, aluminum and this are your cations, so they stay put, your anion switch.
Yeah. That's right. Yeah.
Which means these are now paired up on your product side, and these are paired up on your product side. Now, I'm not saying that this is balanced, and I haven't crossed everything over just yet. However, look at what water is written as. And that is perfectly okay. And this is something that you are going to want to know moving forward. It is perfectly okay to write water this way. And you will want to write it that way in certain situations to help you balance. Okay? So, knowing that, this probably gave you a little bit of fit trying to pick out the right answer. However, what is your correct answer, knowing that these have to be your products? B. Okay? Now listen, I did all of that extra stuff for a reason. It's not like I'm trying to waste your time. I even said to write it down as notes. I'm not trying to waste your time. That's knowledge that will help you out in the future. Once again, this was an extremely fair question. I just gave you shortcuts to get there faster. Okay? Next one. These next true and false, I'm going to write down. I'm not going to spend time explaining each one of them, but if you have questions, we'll take a deeper look into it if we need to. False, true, true. Now, those of my students that have missed it so far have missed one of these first three, 9, 10, or 11. They've missed one or all three of those. The last two, most people have gotten correct. So, are there any questions with 9, 10, or 11 of why you missed it? Huh? Like, have you looked at it yet, or you just want me to spoon feed it to you? You want me to explain it?
Yeah.
Single replacement reactions always take place.
Oh, yeah, never mind.
Good enough? That doesn't happen because the activity series, right? That was in the previous question, all right? Part C.
I want everyone to make sure that this is
Okay, so this is where the mistakes start to come. So this is really where you need to pay attention. This is a good indication of how you're going to do on Thursday, kind of from here on. Okay? So listen. I'm going to say it again. From here on is a very good indication that if you don't do any studying, if you don't do a darn thing from here until Thursday about what you're going to score on your test. It's probably going to be very comparable. Okay? So this first thing is, when I look at these equations, it's always helpful to identify them first. Because of the A, B, the lettering things that we've done, it just helps us picture what we should be getting. Okay? So, what type of reaction is 14?
Combustion.
So you should have written C or combustion on that line. If you did not, I want you to put a big X because that's 1 of 2 points for 14. Okay? I don't care about spelling. If you put a C there, I'm good. Okay? Now, to balance this out, I'm going to walk through this. Hopefully you can follow along with me. Because it's combustion, I know to balance, I need to do my hydrogens first. There's 14. Hydrogen, there's 2. To get 14 on this side, to match that, I put a 7 there to start with. However, I know the rule is, if it's an odd number, I double that number, so it's no longer 7, it turns into 14. Okay? Guys, we are recording, so let's get moving.
Is your face in it?
Yeah.
Your face is in it? Ah.
Okay? So that turns into how many hydrogens?
28.
28. Are my hydrogens balanced? They are not, so how do I get 28 on this side? Put a 2 there. Now my hydrogens are balanced. Now I do my carbons. I have 12 carbons here, 2 times 6. How do I get 12 over here? Just put a 12 in that coefficient line. So now my carbons and hydrogens are good. And once again, I told you that if you're going to make a mistake on these, probably from now on, it's going to be counting up your hydrogen, or your oxygens on this side. So in this term right here, I have 24 oxygens. In the second term, in my waters, I have 14 oxygens. When I put those together, I get 38 oxygens on my right side. How do I get 38 oxygens here?
19.
19 times 2, 38. That's different than 19.
Plus 10, not really. I just forgot the one. I just forgot the one.
What's wrong? Okay, now here, listen up. you need to have every single one of those numbers right to get that part of 14 correct. So, if you've only missed your oxygen, then it's still wrong. 14 is worth 2 points. You got a point for having the right type and for having each one of these correct.
Okay, so what if you got half of it right and the other half wrong?
The one, like,
You got 1 out of 2 points.
So just put one actually like to the side?
No, just put a mark. Put a mark. Number 15.
But then it says balance the equation, which is 3 points, and the reaction points.
I'm not going by that point total.
Oh.
All right. Number 15 is what type of reaction?
Double.
Double replacement. You got to have double replacement here. If not, put a big X over that line. All right. Now, this equation is probably one of the hardest we've done. All right. Now, some of you are going to think it's easy, and that's a good thing, but for most of us, it was a little bit frustrating. And the biggest part is because you see a hydroxide here. Do you see hydroxide over here?
No.
However, what did I just told you? Now, you're right. Absolutely, I could have. But this is very doable without doing it that way.
So it's a free
This is a shortcut. And listen, I did one of these with a student yesterday after school for my tutoring, okay? It took about twice as long, and then I had to go back and simplify all of my coefficients. But it was 100%, you have the skill set to do it that way. The only thing that you would have had to do is split up your hydroxide over here, okay? But you guys have the skill to do that, and we've done that before. Okay? So, but I'm going to do it by keeping my hydroxides the same, because once again, it is a shortcut. So, I have 1 Va, I have 2 hydroxides, 3 hydrogens, and 1 phosphate. I'm keeping my hydroxides together.
Yeah, that's what I'm thinking. Okay.
I'm keeping my hydroxides together. This is the shortcut. Huh? This is kind of a specialty for hydroxide because of water and neutralization with acids and bases. Okay, guys, this is another acid base. Base, acid. But once again, you didn't need to know that to answer the question. I'm just telling you, if you can start to see these things, it just helps you out in the long run. Okay, on the right side, 3 BAs. I'm going to put my hydroxides in the same place as this over here to keep it organized. I have 1 hydroxide, I have 1 hydrogen, and I have 1 phosphate. I do have 2 phosphates. Thanks, Shogun. Okay, so I'm just going to start with my bariums because it's first, right? So I have 3 over here, I have 1 over here. So I can put a 3 there to make that work. However, how many hydroxides do I have now? 6 hydroxides, that's okay. I go over here, how do I fix my hydroxides? Put a 6 there. Now I have 6 hydroxides. How many hydrogens do I have now? Don't say 12. Listen, hydroxides, hydrogens. Because I'm counting them. I'm counting, that's hydroxides, that's hydrogens.
So there's 6 hydrogens and there's
6 hydroxides. Now, if you want to count up the total number, you still get 12.
Yeah, that's
Okay?
why I said 12.
So we have 6 hydrogens. Question?
So if it's not in the sentence, you don't or like not double, like if you don't multiply.
I did.
No, like if like the hydrogen is on the outside of the
It's separate, right?
This 6 goes with that, and it goes with that polyatomic ion, that OH polyatomic ion. Okay? Because I'm keeping them, I'm balancing my hydroxides, I'm balancing my polyatomic ions together. I'm not separating them. That's the shortcut in thinking of water as HOH. Okay? So now that I have that, I have 6 hydrogens, 6 hydroxides. So if I come over here, hydrogens are 3 here. I've got 6 here. How do I make my hydrogens 3 or 6 over here? Okay? So now how many phosphates do I have? Don't say 8. How many phosphates do I have? I have 2 of those things because of that coefficient. So now, 3, 3, that turns into a 6, 6, 6, 6, 6, 2, 2. I have a balanced equation here. 3 to 2
I got all of the sides.
to 1 to 6.
That is
I
far
got
from
like
what
I
I
did
got.
them all individually. I did them all individually and I got double them. Like,
So what you got, listen, that's what I was talking about. So, listen, if you didn't do the hydroxide way, which I'm sure most of you didn't because you didn't know about that, if you didn't see the hydroxide in there, what you would have probably gotten was 6 to 4 to 2 to 12.
Yeah.
And what I'm going to tell you is,
It's still
it took you longer to get to the right answer, but you got to the right answer. But I did tell you, in the notes we're doing all this stuff, what do you need to do?
oh, to simplify.
to simplify.
You need to simplify.
Oh, my
So if you did not simplify, you got this one wrong. But listen. You balanced it correctly.
Yeah, I just-
100% correctly. It took you longer than what it did me. Okay? But we should have still got the same ratio if you simplified. Okay, once again, I'm telling you shortcuts. I'm not necessarily teaching you anything extremely brand new. Okay? Yes. So from now on, you are putting your pen down.
Could you go over one of the like bottom ones? Because those are like the hardest.
We're doing all of these.
Oh, okay.
Together?
He said you'd put your pen down.
Put your pen down. And guys, listen, we got to go quickly here. So the side conversation, all that kind of stuff has got to kind of stop so we can get through this.
Are we not doing a release day?
No, you have, it's homework. Okay, ready?
Wait, what's homework?
And the whole.
Strontium chloride. Strontium has a +2 charge. Chlorine has a -1. That is chlorine, not chlorate, not chlorite. Right? So, strontium, Cl2, that's one of your 5 points.
Yeah, I know.
Added to, ammonium has a +1. Sulfate has a -2 charge. Ammonium is NH4. When I cross that 2 down into it, I get that SO4. That's your second point. From there, I should see that this is a double replacement reaction because of my A, B, C, D. I need you all paying attention up here, please.
Oh, I didn't do that.
From there, I have my metals that stay, my cations that stay in the same spots, and I switch up my anions. So SR is with SO4. That's added to NH4 Cl. Now, what I have not done yet is, guys, is crossed up my oxidation numbers. So, +2, -2, +1, -1. When I cross all of those up for each term, they cross each other out. So this is what I'm left with. Okay? From here, because it's double replacement, what should I look at? Your solubility chart.
Oh man. That's what I did. I forgot about it.
Your solubility chart. And you should have seen, do any of my products form solids? Which one? The first one forms a solid. If you forgot how to use a solubility chart,
Yeah.
go look at it. Look at your anions, sulfates. So look at sulfates. Sulfates are always soluble unless they're paired with, one of those exceptions, is strontium an exception? Yes, it is. So that turns into a solid. Question? No question? Okay? This one will be aqueous because it'll always only form one solid if it is going to form a solid.
Do the plus 2 mean anything?
That's just their charges. That's just your charge, right? So because this is a good reaction, remember a good reaction means a solid is formed, then I need to go through and balance this. So what you have right here is 4 points, and then you should have balanced it with a 2 right there.
So if you didn't balance it, but you have to write like slight.
You got 4 out of 5 points.
Oh, okay.
Question.
How about if you got the first part, the reactant?
Listen. 1, 2, 3, 4, 5. You tell me how much, I'll tell you how much you got right out of there, but you can see on your own. Okay? Because I want to see it. Next one. Magnesium is added to lithium chloride. Once again, magnesium is a diatomic.
No. No, it isn't.
No. Lithium plus 1, chlorine minus 1. When I cross those up, what do? Cancel each other out. And this gives me. Now, I would prefer that from now on you always give me the products. I know in the directions it said that if there is no reaction, you don't need to write the products. But I will never count off if you write products with a no reaction. Okay? So, if this were to happen, magnesium is a metal, so it wants to kick out lithium, which is a metal. So if this works, it'll be lithium plus MgCl2. Now, because it's single replacement, you should be going to your activity series. Correct? So, does magnesium fall higher than lithium?
Nope.
It does not, so will this reaction work? No reaction. Watch your point. You got a point here, you got a point here, and then you kind of got 3 points for having a no reaction. If you went and balanced it, I'm taking another point off. Because there's no reaction. You don't balance no reactions. Yeah.
Wait, so, but if we didn't write the products and we just wrote no reaction, we still got the points?
Yeah.
Okay.
The next one. Sodium carbonate. Sodium plus 1, carbonate minus 2. Sodium carbonate is added to, is mixed with ammonium, which is plus 1, chloride minus 1. So those cancel each other out in H4Cl. 1 second point. That gives me, what type of reaction is this?
Double.
Double replacement, which means sodium will now be paired with chlorine. Ammonium will now be paired with carbonate. Because carbonate has a minus 2 charge, that's why there needs to be a subscript 2 right here. Right? So 1, 2, 3, 4. Your 5th point comes as a double replacement, so what should you look at? Solubility chart. When you look at your solubility chart, are either of these two aqueous, are either of those two solid? Guys, did you use your solubility chart? If you didn't pay attention to that lesson, or you didn't do the homework before you took the quiz.
I wasn't here.
It's online.
I tried watching it.
Yeah.
Okay? So when you do that, both of these come out to be aqueous. Yes?
Didn't you say that one of the products always has to be solid?
If the reaction works.
If
Because both of these are aqueous from our solubility chart, no reaction. No reaction. Okay? So, there's your 5th point. Huh? No, I like doing that.
Okay, moving on.
Next one. Potassium is added to nitric acid. First off, every acid has hydrogen in it. Nitric is missing what key word? Hydro, which means I should be looking for a polyatomic ion. Nitric comes from nitrate, which is NO3 with a -1 charge. So HNO3. What type of reaction is occurring here?
Triangle replacement.
What type of reaction is occurring here?
Synthesis?
Single replacement.
Single replacement.
Oh.
Now, this is why I told you that this reaction does occur, because you would have not found this in your activity series. So, hydrogen gets kicked out by potassium. KNO3. If you wrote that, why is it wrong?
Because you didn't do the crossing out the subscript.
H2. Guys, stop talking. Please watch. Because I've had almost all my kids miss this one.
Okay.
H2 is diatomic. Then you need to go through and balance for your 5th point.
All of that. I did all
Okay? The last one. Your hydrocarbon is added to oxygen because it's combusted. Once again, please stop talking. Thank you. Your hydrocarbon is added to your oxygen to give you plus H2O. This is a combustion reaction. You got 1, 2, 3, 4 points for knowing the components of combustion.
Yeah, I know that.
If you didn't balance it right, you still got 4 out of 5. Now, if you did balance, it should be 11, 7, and 8.
Yeah. Woo! So smart.
All right? Fast forward your quizzes.
But you're Mr. Steinke, you're gonna be grading it again, right?
What?
You're gonna be grading P right again.
Yeah.
I'm 19 if I
That's fine.